Hey everyone, welcome back to my channel. In today's episode, we're going to be creating an awesome enemy drop effect where the player absorbs and attracts particles when they're within a certain range. We'll be building this effect from scratch using the Niagara System and exporting particle data to a blueprint. But before we get started, please take a moment to hit the like button and subscribe to the channel so you won't miss any future episodes. Now let's go ahead and get started. To begin with, we're going to create a custom texture for this that we're going to use in our material. To do that, if you've seen any of my videos, I like to use 3D Paint. And we're going to make a real simple texture for this. It doesn't have to be anything crazy. This is just going to be the smoke off of our tail. And for this, I'm just going to make this a 512 by 512. It's grayscale, so I'm going to do a black background. And I'm going to grab some spray cans. I'm going to start darker and kind of go lighter to a brighter white as we go. Do some of this in here like this. It doesn't have to be perfect. We want a lot of variance and we want this to kind of look like smoke in some spots. So that's going to be all we need for this. So I'm going to go ahead and save as, and I want to name this smoke 2. And then I'm going to go ahead and import that into my project. The next thing I'm going to do is create a material for this. So I'm going to right click, add a new material, and I'm just going to call this tail. And inside this material, we want our material, if you click the output, we want to come over and we want to say translucent and unlit. And this is really just a basic material that I make for a lot of my projects here. We're going to use that particle color. We're going to go ahead and do a multiply off of this. This will plug directly into our emissive color, and then what we're going to multiply this by is going to be our texture sample mixed with the radial gradient. So I'm going to get a texture sample and a radial gradient. This, I'm going to come off of my red from my texture sample, and I'm going to say multiply. And this multiply is going to plug directly into my right here. And I'm also going to do another multiply off of this. And this is going to come off of the alpha of our particle color. And then this will plug into our opacity. I need to go ahead and add my material into here. And it was my smoke material here. I did get an ugly line here, but I'm not going to worry about that too much for this. You can always redo your material after you build this. So if you don't like it, you can redo it. Off this radial gradient, I'm going to come out behind the density. I'm going to hold S and click and just get this parameter here, this scalar parameter. And for now, I'm just going to set this to 1. This will be the actual density of our gradient. So if you play with this, you can kind of see what it does. Right now, we just kind of want it real faint, and we'll play with that as we need. Off the back of the UVs for your texture sample, I'm going to come off this and do a panner. And with the coordinate here, I'm going to end up multiplying a couple things together. And this is going to be my text coordinate, if you get a text coordinate. And I'm going to use a dynamic parameter here. And I'm going to control both this tiling at the same time. And to do that, I'm just going to plug this into 1 and this will multiply these chords by whatever we use for this parameter, which I'm going to come over here and I want to rename this first parameter to tiling. And in fact, instead of doing this right here, I'm going to make this a parameter as well. I'm going to set this one to 4. So we can remove that for now. And then we'll change this inside of our Niagara system once we get to it. And for our tiling, I'm going to come, or off the speed, I'm going to come off here and I'm going to say append vector. And I'm going to plug both of these in here. And then I'm going to make param2, I'm going to call xpan speed. And then parameter 3, I'm going to call y pan speed. And you see that's got our texture or our material spinning pretty quick, but we'll change that, like I said, in the actual Niagara system once we get to it. And this is all we're going to do for this material for now. So go ahead and save that, apply it. The next thing I want to do is start building my Niagara system. So I'm going to right click Niagara system. And I'm just going to get an empty system. And I'm going to call this NS drop FX. Let's go ahead and open that up. And inside here, we're going to do quite a few things. First, I want to rename this to maybe drop particle. And I want to go to my emitter state. And I'm going to say self. And I'm just going to do once right here. And give this like a loop duration of maybe 5. The next thing we're going to do is I'm going to add a burst instantaneous. I'm going to end up setting this to 50, leave the spawn time where it's at. Down in the initialized particle, to keep this alive for a while, I'm going to set this to something like 50, and that's something that can be adjusted as we go. And I'm going to do a direct set for the color mode. And for this, I want to pretend like it's maybe a health pickup. So I want to make this some sort of green, maybe something like that. And maybe we don't want any red. The next thing I'm going to do is give this a shape particle or a shape location. And for this, I'm just going to do kind of a small sphere. And we can adjust this as well as we go. I did forget an initialized particle. Let's go ahead and let's set sprite size mode. Let's go uniform, and I'm going to do something kind of small, maybe 5. The next thing I want to do in my particle spawn is I'm going to do an add velocity. Go ahead and fix your issues when you get those. And the velocity that I want to do, I want this to kind of look like a fountain. So we actually could have started with a fountain template, but I like to just do it from scratch. So I want this to go on your velocity. I'm going to do a random range vector. And I want this to go something like -100, -100. I only want it going up though, so both of these z's are going to be positive. I want to go 300, and then here I want to go 100, 100, and maybe like 500. That way it's looking kind of like a burst or a little firework almost. And that's all I want to do in the particle spawn for this one. In the particle update, We can do quite a few things in here. Let's do a scale sprite size. I like to do the drop off on this one. So the longer it's alive, it gets a little smaller. And then right before it dies, it shrinks really fast. I'm also going to do just a drag to get a little bit of natural feel to it. And I'm just going to do a small drag. The next thing I want to do so we can see this kind of fall like an actual particle is I want to do a gravity force, but I don't want full Earth gravity. I want these to kind of float a little bit. So I'm just going to knock that down to about half. That way it shoots up and it's going to fall and stick to the ground. And to make it stick to the ground without falling through, we're going to add a collision. To add a little more randomness, I'm also going to add a curl noise force. And this can be anything. You can play with this number to get it where you want it. I'm just going to do something like this for now. Also going to do maybe a scale color. And we're going to do the alpha here. And on the alpha, I'm going to do a random range float from curve, sorry. And I'm just going to leave it like that. So the longer it's alive, it fades off. But I want this linear ramp down. For this curl noise, we want, or the collision, we want to make sure this is the last thing that happens before Saw forces. This will keep it from falling from the ground. You might have seen that fix in another one of my videos. So we now have our particle doing what we want. And before we get into attracting this to the player, I'm going to go ahead and do another emitter here. And I'm going to do a tail for this. For the tail, I'm going to click on the emitter state and I'm going to go to System and Infinite. So the tail is always there. And then I'm going to do a spawn particles from other emitter. Make sure you fix any issues. And the emitter I'm going to spawn this from is going to be that drop particle. And fix that issue as well. And I'm going to take this to something like 250 and 250. Again, this is something that can be changed as you go. For my initialized particle, I don't want this to be alive for 5 seconds. That's why you're seeing these long tails like this. So I'm going to do a random, and I'm just going to get this real short, maybe 0.2 to 0.4, so you get shorter tails. I'm also going to go ahead and do a direct set for the color. And for this, I want this pretty emissive. So I'm going to do something like 1,000 here. And we can change this as we go as well. Sprite size mode, I'm going to do a random uniform. And this is going to be between 2 and 10. I'm going to do a shape location. We want this to be a small sphere behind our particle. Right now, it's a huge sphere, so wherever there's a drop particle, it's got a radius of 100 around that can spawn these in. So I'm just going to do a real short one for now. This is also super bright, which is not what we want, and that's actually going to be part of our the density in that material that we created. So I'm going to go ahead and get our dynamic material parameter out for the Oh, we have to set the sprite renderer to that material first. So click on sprite renderer, and here we're going to say tail. That's what I named my material, but whatever you named yours. And now that we have that set, we can go to our dynamic material parameters. We want to set our tiling right now to 1. Um, the pan speeds, we can mess with those in a second, but I want to set the density to 1 so that we can start to see that tail. And it's possible that that's a little too bright. So let's mess with this a little bit just to get it to kind of fade more. And some of this we're going to affect also with like scale sprite size and scale color. So I just kind of want something like that for now. And then this pan speed, I'm going to do something like, I want something slow in the X and Y. So do something like 0.1 and 0.1. Really, we're not going to see this much at this small scale, but just to add a little bit of randomness and motion in those little particles, we'll do a short, small little slow pan in the X and Y direction. All right, so back to our particle spawn. Let's do, that actually might be all we need in those two. So in the particle update, let's start changing some of these. So I want to do a scale sprite size. And for this, I just want a linear ramp down. So it kind of fades off the longer it's alive. You can kind of see there it's brighter here and fades as it goes back. I want to add a drag, just a short little drag there. Add a curl noise force for a little bit of randomness. And this we can play with as well. You can see kind of how much it's going to affect it there. So I might just do a short one there or a smaller value there. So maybe like 250 or 200 for now. We can do a scale color. And on the scale color, I'm just going to affect the alpha here. So come off the alpha, and I want to do a float from curve. And again, just that linear ramp down to get it to fade as it goes. And you can add keys here and have it fade at different points in time to see what that looks like. I'm just going to leave mine something like that. It doesn't honestly matter for what we're doing. If you zoom in, you can see that panning taking place there. And in fact, while we're in here, I'm going to change this tiling a little bit because I'm getting some hard lines in between where my UV or my textures end around the border. So I'm just going to do something like a 0.8 or so just to add a little bit of randomness there. And we can also do, let's see if this makes any difference, sprite rotation mode. We can do this to random as well. Just going to rotate each sprite that's alive. So some's going that way, some's going that way. Just adds more randomness to it. So now I think I'm going to leave mine like that for now. I think that looks pretty good. We could actually also move this down into the update if we wanted to. But I think that looks pretty good right now for a tail. And let's actually go ahead and throw this into our level and see what that looks like. To do that, I'm actually going to turn this to infinite so that I can watch it continue to um, burst. And I think that looks pretty good. We can always make that tail thicker, which I might go do. Let's do that. Let's go into our initialized particle and let's go from 2, or let's do this in the scale sprite size. That way, whenever it's at its full value here, 5 is too big. That might be a little better. And then we can also change the life of this so it's a little shorter tail, so they fall off a little quicker. So I think that looks pretty good. And we see our smoke kind of looks randomly floating. So I think that looks good. So I think that's going to be good enough for our particle here. Now we're going to set up letting our player activate this to attract to the player whenever we walk within a certain distance from this. So to do that, if we go back into our Niagara system, we need to set up a few things in here for this to work correctly. The first thing I want to set up is an export particle data to blueprint. And inside here, I'm not going to give this a condition to export it. You can have this to where if it collides, then it'll export data, or if it, you can come up with all kinds of conditions to replace this with. I'm just going to check this true, which will have it continually sending the data. And then see this callback we need to create, and we'll do that here in a moment. We're going to leave this as a fixed size. We can do it per particle, but we're going to use it as a fixed size here. That's all we need to do for now. Let's go ahead and create this callback here. To do that, I'm going to go over to my user parameters and I'm going to add a new one. And I'm going to add a object, a reference to an object here. And I'm going to name this particle callback. We don't need to set anything here. But now that we have this set up, we can come over to our callback handler and I'm going to select particle callback here. The next thing I'm going to do is go ahead and get ready for this to be attracted to our player. And to do that, I'm going to create a spring force. And in this spring force, I want to set the force strength to another user parameter. And I'm going to change this name to just force. And then for the particle equilibrium, I want to set this to a user parameter. And this particle equilibrium, I'm going to rename to actor location. Let me expand this so you can see what I named mine. And those are going to be okay for now. I'm going to go ahead and set the spring tightness down to maybe 10. And these will set within our blueprint. So if we come back out here, we want to create a blueprint. I'm going to just make a new one. This blueprint would actually be handled in maybe an enemy blueprint, and you would, whenever if the enemy dies or a chest opens or something breaks or wherever you want to spawn these particles, you would do it in that blueprint. But for this example, I'm going to create a new blueprint, and this is going to be an actor. And I'm just going to call this BP drop. And let's go ahead and open that up. Now, inside of this, I'm going to add that Niagara system. With this Niagara system selected, I'm going to come over to my details panel and I'm going to select that system for the Niagara system asset. And I'm going to keep this on auto activate for now. And then over in the event graph, you don't need these. So we're going to do a couple things here. One of them is we need to implement an interface that is a part of this. We have an interface that we can use in the system for Niagara systems. And to implement that, we're going to go to class settings. And down in your details panel and interfaces, we want to go to add implemented interfaces. And I'm going to look for Niagara, and we want the particle callback handler. And that gives us this receive particle data interface function that we can use. If we double click that, it'll give us a reference to it out in our world. And this gives us an array of all the data that that's sending. If we go look at our export particle data, the things it's sending are these three right here. You can always change them out if you want more or want different ones. We're going to use this position one. That's the only one we want. So I'm not too worried about the other ones here. So if we come out to our event received particle data uh, here, we can come off of the data and say for each loop. And what we want is to get in this array element, we can break this or split this struct, and we can see all the things it's sending us. We're getting the position of the Niagara system, the size, the velocity. So we're already getting these things. And what we want to do is check the position of this compared to the position of our player. And if it's within a certain amount, then we're going to set that spring force value, which will allow the particles to then be attracted to our player. So to start with, let's go ahead and say, if we right click and say get player character, and from here, I'm going to come off and I want to say get world location of the mesh. And then I'm going to also get the location here, and I'm going to subtract the two of these. And if we do something like vector length will work, but if this vector length, the difference here is, we'll say less than, and for now, I want to set this to 50, and we can play with this if we need to. If it's less than 50, then we're going to do something, so do a branch. So if this is true, then we want to set those parameters for the force, for instance. So to do that, we're going to grab our Niagara reference here and pull off of this. And I'm going to say set Niagara variable. And this first one's going to be a float for the force. Just connect that up. And the variable name is going to be whatever you named your force variable here. I named mine just force. You can copy and paste that in or just type it. Make sure you don't misspell it or it won't work. And to begin with, I'm just going to set this to maybe 2 just to get a force going. So if we go out into our world, let's get rid of this for now. Let's actually, before we do that, we actually won't see that get attracted to us yet. So there's still a couple of other things that we need to do. we actually haven't set our reference to this blueprint to be able to use that callback, this particle callback here. So we need to set that real quick. And to do that, we're going to do that just on this event begin play. So right whenever this blueprint is in play, we're going to grab this Niagara system here. And from here, we're going to say set Niagara variable. And now we want a reference to an object, which if you remember is what we name, or the reference type of this callback. Go ahead and connect that up. And this variable name is going to be particle callback here. So you can copy and paste that name or type it in right there. Well, don't do that. That was a mistake. Don't do that. I'm actually just going to delete that and do another one. Niagara. Um, and it's going to be a variable object. Connect that. And mine was particle callback. So I'm just going to do like that. And we need to reference an object, and the object we want to reference is this blueprint here. So I'm just going to say self out of this, so get a reference to self. And this is allowing this blueprint to use this particle callback. For now, that's all we need there. The other thing that I'm going to do, just to get ready for attracting this to our player, is I want to come down here and I want to do an event tick. And in this event tick, I'm going to constantly be setting that actor location to wherever my player is. Um, this way, whenever this does have a force, it doesn't just go to where we were in the instance that it was attracted to us. It will continue to follow our player. So below this event tick, I'm going to say get player character. From here, I'm going to say get world location of that mesh. And one thing we're going to have to do is offset that. This mesh, it's going to have the location right in between the character's feet once we get this set up. So we want it to be about halfway up the body. So I want to come off of this and just say add. And I'm just going to do kind of an offset in the Z direction. And we may need to change this as well. And then on this event tick, I want to drag out a reference to that Niagara system. And I'm going to say set Niagara variable. And for this one, I want a vector 3. So grab a vector 3. And we're just going to plug this value in right there. And for this variable, this one is going to be the actor location. So we'll type in actor location. So now if we go out to our game here, if I pull out one of our references, it's initially trying to go out to the world, which is 000, and we don't want that. So let's look at our spring force here. Definitely not what we want it to do. Let's do, um, let's look. Oh, to begin with, we actually want to set that spring force to 0. So that this is one way to overcome this. We want to come into our force, and instead of having a force of 1, we're going to have a force of 0. That way, this isn't attracted to anything until our player interacts with it. So that's one way to solve this issue. So now it just kind of falls where it's at. If we play this, and then it's attracted to our player, and you see they kind of linger around. So the next thing we want to do is, unless this is what you want for your game, the next thing we want to do is have this. Um, we want to come to our Niagara system, and we're going to add a kill particles in volume, and we're going to set this volume origin reference to our actor location. So just drag your actor location over to there. And this sphere, we don't want it quite so big, so it looks like it's still getting to our character, but we also don't want it too small to where it keeps just bouncing off of our character. So we're going to do something like that for now and see what that looks like. So that kind of kills them off. The next thing you see is it's still attracted to our player as we run around. So we need to reset that force after we've picked this up. To handle this for this instance, we if you're going to have something in your game where this is going to keep spawning in the same area, then you'll need to handle it the way that I'm about to handle this. If this is a one-time fire and it never goes again, it'll take care of itself. Um, but even then, you might want to come up on your event begin play and reset that force to 0, which is a way to make sure that it stays that it's not attracted to anything until you want it to be. The way I'm going to handle this is I'm going to create a custom event, and I'm just going to name this spawn drop. And for now, after um, on the receive particle data, I'm just going to come off of this and set a timer by function name. And this function name is going to be the event we just created, drop or spawn drop. And I'm going to have this go off every 5 seconds and loop it. That way, this just continues to shoot particles out. The other thing I'm going to do is come back into here on my emitter state, and I'm going to take this back to once. And let's see how long this is particles alive for. I think at 50 seconds. I want to take this down a little bit as well. And now that so once this gets to this set timer by function, it'll kind of set a loop where every 5 seconds it'll run this spawn drop event. And inside the spawn drop event, we're going to reset our force back to 0, and then we're going to reactivate the Niagara system. That way, right before the new Niagara system is spawned, it's setting the force back to 0 so it's not attracted to our player. So I'm going to pull out a reference to the Niagara system, and I'm going to say set Niagara variable, and we want that float. And again, we're just setting the force here back to 0, so make sure this is 0. And then I also want to come off this Niagara system and say set active. And then I'm going to check both of these. So now every 5 seconds, we should get another fire of this. So let's check this. And there's the other one, and it's not attracted to us anymore. So now we can go pick this up. And some of the things you can do to change this and customize it, obviously you can change the color or the tail around. Maybe you don't even want a tail. You can also do some sort of other little emitter after it's been killed, some sort of like a little explosion or something like that. Lots of ways to customize it. This was just a quick little tutorial to set this up. Some of the things that you may want to do different is instead of resetting this here, if it's just for an enemy drop, you may want on the begin or event begin play to set it there. That way, as soon as this comes alive, it's setting that force there. But this is a good way to handle it too. If you're just going to keep it going, kind of like a fountain. We can also let's change this to like 2. Now let's put a few of these out in the world so we can watch this happen with multiple that continue to refire. So we immediately grab that one. We can almost outrun them. You can change that, how fast they're attracted to you as well. And to do that, you can do a couple things. We can increase that force, or we can go do on our spring tightness. We take that to like 20 and then play it. It's a little faster coming at us, so we can't outrun it. So that's our final product. Like I said, lots of ways to customize this and plenty of ways to use it in your project, I'm sure. But that's going to do it for this episode. In this episode, we successfully created this enemy drop effect using the Niagara system and exporting the particle data to a blueprint. I hope you enjoyed this process and learned something new. Don't forget the like button and subscribe if you haven't already so you can stay up to date with all the future episodes. As always, happy developing, and I'll see you in the next one.